actually going to start calculating some what we call individual statistics. So the statistics that we're initially going to calculate here, this only has to do with the risk of the return of the individual securities. And now, we've calculated the mean of the securities, we calculated the deviations for the security and for the market. Now remember, if you had enough observations, all these deviations would sum to zero. That's not what you want when you do statistics. So to get around that now, we square the deviations. So we're going to take the deviations for the security and square it, that is, raise it to the second power. And we're going to take the deviations for the market and square those deviations. So for instance, the deviation, the first observation for the security deviation was 3.67. If you square that, you get 13.44. And if you take a negative 6.33, square that, you get 40.11. Now note, when you square everything now, you get rid of all the negatives. A negative times a negative is a negative. A negative times a negative is a positive. And so when you get a negative 6.33 squared, this turns into a positive 40.11. And we did that for each of the deviations for the security. So we took each of these numbers and squared those numbers. The first statistic we're going to calculate now for the security is the variance of the security. Now, variance is the mean of the squared deviations. And when you have a historical distribution, the way you calculate the mean is to calculate an arithmetic mean. So we're going to sum the observations, divide by n. So here are the squared deviations here. If we sum all these observations, we get 205.33. Now, when we go to calculate the mean of that, we need to divide by n. But because we have sample data now, the denominator is n minus 1. So we're going to take the sum and divide it by n minus 1. So we're going to take 205.33 and divide it by 6 minus 1, which is 5. So if you take 205.33 divided by 5, you get 41.07. And that's the variance of the distribution. Variance has no unit value. This is not 41.07%. It's not 41.07 horses. It's not 41.07 anything. It's just a number. But what we can say, though, is that the greater the variance, the greater the risk. And again, this is the variance now is simply the mean of the squared deviations. We took the sum of the deviations, got 205.33, divide by n minus 1, 6 minus 1, or 5, and we got 41.07. And that's the variance of the distribution. The next statistic you calculate now is standard deviation. And standard deviation is defined as the square root of the variance. So the square root of 41.07 was 6.41. Now, because we're squaring it and bringing it back from this squaring business now, it gives standard deviation a unit value. And the unit value of the standard deviation is whatever the unit value was for the distribution. And note that the distribution value is in percentages. So when we say 6.41 is the standard deviation for the security, we mean it's 6.41%. That's the standard deviation. It takes on the same unit value as the distribution. Two other common statistics that you see calculated in finance and investments and the like now. One's known as the coefficient of variation. The coefficient of variation is the risk per unit of expected return. Its formula now is the standard deviation divided by the mean. Risk per unit of expected return. Risk is standard deviation. What do we expect the return to be? The mean of the distribution today. So when we talk about coefficient of variation, it's the risk per unit of expected return, 6.41 divided by the mean, 4.33, gives us a coefficient of variation of 1.48. As a finance person now, as a business person, you want the most return for the least amount of risk. The coefficient of variation, 1.48. This means that for every unit of return, for each 1% return you get with this security, you're taking on 1.48 units of risk. As a business person, as an investor now, of course, you want this number to be as low as possible. I want the least risk per unit of return. So all things being equal, you like the coefficient of variation to be as low as possible. Another common statistic calculated now, this is called the Sharpe ratio, after William Sharpe. Now, it's a kind of a variation of the coefficient of variation. That is, Sharpe said, people don't think in terms of risk versus, in terms of risk relative to return, but they do think of return relative to risk. And so the Sharpe ratio is simply the inverse, if you want, of the coefficient of variation. Coefficient of variation, recall, was the risk per unit of expected return, the standard deviation divided by the mean. The Sharpe ratio now is the return per unit of risk. So you have the mean in the numerator and the standard deviation in the denominator. And so to calculate the Sharpe ratio for the security, we take the mean of the distribution, what we expect the return to be in the next time period, 4.33%, and we divide that by the standard deviation of the security, which is 6.41. And this turns out to be 0.68. So what that means now is that for each 1% of risk that you take on, for each 1% of standard deviation that you get with this asset, you're receiving 0.68% or 0.68 units of return. All things being equal, of course, you'd like to have more return per unit of risk. You'd like the Sharpe ratio to be a higher number as opposed to a lower number. And again, this is the coefficient of variation and the Sharpe ratio for the security. Now we calculated the same statistics for the market. And so to calculate the variance of the market, we need to calculate the mean of the squared deviations for the market. Here are the squared deviations. We sum those observations, got 237.33. We want to find the mean, so we take the sum, and again we're going to divide by n-1, or 5 in this case. And we get a variance of 47.47. Again, it has no unit value. But what we can say is that when we compare the market variance to the securities variance, we see that the security has less risk than the market does. To calculate the standard deviation for the market, we take the variance, 47.47, we take the square root of that, and we get 6.89. And again, standard deviation now takes on the same unit value as the distribution. So this is actually 6.89%. Standard deviation, just like the variance now, the greater the standard deviation, the greater the risk. And what you see here, again, is you have the market having more risk than the security. To calculate the coefficient of variation for the market, coefficient of variation, the risk per unit of expected return. So it's going to be the standard deviation, which is 6.89, divided by the mean of the distribution for the market, which is 3.67, and we get a coefficient of variation for the market of 1.88. To calculate the Sharpe ratio, it's the return, the expected return, divided by the risk. So the return, the expected return, the mean of the distribution for the market, 3.67, divided by the standard deviation of the market, which is 6.89, gives us a Sharpe ratio of 0.53. Now, often in business, in finance, you're asked to choose between assets. To be a rational investor now, you want to choose the one that gives you the most return for the least amount of risk. Statistically now, you want to use either coefficient of variation or you want to use the Sharpe ratio to choose between assets. If you were looking at the coefficient of variation, you'd want to choose the asset now, assuming they're both acceptable to you. You'd want to choose the asset that gives you the least amount of risk per unit of return, the one with the lowest coefficient of variation. And that's security I here. Its coefficient of variation is less than the coefficient of variation for the market. You could also choose on the basis of the Sharpe ratio. Now the Sharpe ratio is return per unit of risk, and you want the most return per unit of risk. You want to choose the asset that has the largest, the highest Sharpe ratio. And again, you'll note here the security is superior to the market because you have a higher Sharpe ratio. Now, the Sharpe ratio and the coefficient of variation will always tell you to choose the same asset. Okay, so both tell you to choose the security here rather than the market. As a rational investor, you want the most return for the least amount of risk. That's why the Sharpe ratio kind of ties into that Sharpe's concept. But you will not, if you're choosing between two assets, the coefficient of variation and the Sharpe ratio will always point you to the same asset. You will not get conflicting signals there. Okay? If you do, you made a mistake. What we've done to this point now is look at statistics that look at the risk and return of the individual asset. In just a moment now, in the next video, we're going to go into some statistics that look at the relationship between these assets, and I'm going to show you why it is you would want to do that kind of thing. It's a portfolio kind of concept, but we'll talk about that in the next video.